Alright, let us get underway. A lot of this particular presentation you will go, "Ooh, I've seen that before." And that's because Chapter 5 in IT Essentials and this chapter do cover a lot of the same ground, but there are some differences. So we'll just work our way through. Again, this is going to be a fairly lengthy presentation. It's basically looking at the components, the topologies used, types of connections, types of networks, and some of the trends that have been occurring in networks, some basic security concepts, and as it is a Cisco marketing course, we have to talk about the Cisco qualifications and so forth at the end of the chapter. So networks are affecting us in our daily lives now. We basically have a instantaneous communication with almost no boundaries around the world. There are countries that impose boundaries, so that statement's a little incorrect, but Cisco likes dreaming. So you can create global communities online, and you see that if you're gaming or anything like that, you will certainly come across a global community in that aspect. And it helps connect people together, especially in these trying times of the global health issue. And technology does play an ever-increasing role in how people react and communicate with each other. So host roles, we talked about this. Your servers are computers dedicated to providing services to the users of a network, and clients are the users of those services on the network. So they are both end devices. In other words, they both make use of a network, but they have two distinct functions from each other. Whereas in a peer-to-peer network, we blur the lines between who's the service provider and who's the client. So in a peer-to-peer network, both machines are clients and both machines are services. So they both offer a service to other computers on the network and are both clients of the network. So what constitutes an end device is anything that uses the network to transport data or to receive data. So your PCs, your laptops, your phones, printers, servers, all of those things that are using the network are part of end devices. The ones that help get that data to the end device are the ones that are called intermediate devices. These devices basically boost the signal, regenerate it, apply policies to the traffic as it moves through, fixes and errors when appropriate, looks for dodgy traffic and takes action through our firewalls and intrusion detection devices. And interconnecting all of these devices, we have media. That media is normally copper, but fiber is becoming more popular, so is wireless. Now, every media type has its pros and cons, so we'll look at those in more detail in the chapters to come. Okay, so you can see here they basically use exactly the same network topology diagrams or icons as what we have seen in the ITE course, and that should be help you familiarize yourself with the diagrams that we will be using throughout the course. Now, topology diagrams come in all shapes, sizes and variations, but the two main variations is a physical topology and a logical topology. Now, you're going, oh, what's the difference? Well, on the physical, you basically record physical characteristics, so the location in a building, room number, what rack the equipment's in, what shelf it's in. So physical characteristics. Whereas a logical topology is talking about the things that we assign based on its function, such as the IP addresses, the network groupings of devices together. So they're quite different in their functions. So you'll notice on the left one, which is a physical, there's no connection information, it's just the physical location of the devices. Whereas on the right one, you have the interfaces in use, and the reason behind that is you will generally have the IP addresses where appropriate for the individual devices as well. So common types of networks are, the one that you use at home, a small office, or a home office, which Cisco refers to as SOHO. You then get to your enterprise level offices, which use dedicated systems and can be in a single or multiple locations. And then you go across to the worldwide network. So anywhere in the world, such as our international companies use offices in every country. So how do we define the types of networks in relation to geographic size? Well, if it's within basically the same location, we call that a local area network. Where we branch out into multiple locations around the state, the country, around the world, we need to interconnect those vast distances using wide area networks. So each location has a local area network, and the networks that interconnect them is our wide area network. So I won't read this one. So basically, same organization, local administrated for the LAN. WAN is administrated by a team, and your WAN links are very much slower than LAN links. They tend to be about 2 megabits per second, and with your LANs you're getting gigabits per second now. So the internet, you use it every day, so it's just a bunch of networks interconnected together, and they have groups that are agreeing to share their resources to allow traffic to pass through them so that everybody can connect to everybody else. There are financial agreements involved and contractual agreements, but the standards and everything and addressing is basically maintained by a groups of organisations that come up with how traffic is to be forwarded, addressed, all that sort of stuff.
Uh-oh. Oh.
We have a loop back. You put the speaker too close to the microphone. Okay, intranets and extranets. So basically, an intranet is within the organisation for staff. Extranet is where we collaborate with our suppliers, our customers, who basically have access to our resources and systems in a limited fashion. And then we have everybody else in the internet. Went through this a couple of days ago, so I'm not going to spend time on it. Just be aware that there is a difference between a home service and a business service. You basically have the same types of services, but they're business grade. So your satellite, your DSL are all going to be a business grade DSL or business grade fiber connection. So these things have a contract that says the service provider will have X amount of bandwidth available, and if they don't, there's penalties involved, and the client will only send X amount of data, or else they get policies applied for shaping traffic, all these sorts of things. And there's, businesses pay for every megabyte of traffic that they send and receive. Okay, it's not like the home grade service where they just pay a flat monthly subscription fee and get to use as much of it as they want. They actually have to pay a monthly fee for the guaranteed service, and then they have an allowance of traffic, and then they pay in excess for more traffic than that contracted allowance per month. Okay, traditionally telephones, our video services and our data services were all on separate dedicated networks that had their own rules and standards applied to them. They did not mix. Now, under converging technologies and networks, we run all of these services over same network infrastructure using IP traffic, using policies put in place saying if it's a voice call or a video call, it has higher priority than data. And you're going, but it's IP traffic, so it's all data. Yes, it is. But it has a service agreement with the network saying, I'm a VIP, I get to go through the queues fast, just like at the airport for the business and first class lines at security against the rest of the plebs on the other side. So when we design a network, we refer to network architecture to describe the methods and that we use in the design of moving the data from point A to point B. But 4 main characteristics need to be applied to the design. We need to have the network fault tolerant. So we need backup systems, backup routes, fall over, fails, safe, whatever terminology your particular also wants to use. Scalability, in other words, we need to be able to add parts to. Oh dear, Jacob. Okay. Jacob's keyboard's just gone on the fritz on him. All right, so for scalability, we need to be able to add components into the network without affecting the rest of the network in a negative way. If you've designed the network correctly from the start, if it hasn't grown organically in a bit of a mess, you can copy chunks called modules and just duplicate it. So you're using basically the same spec hardware, same spec cabling, and you're applying the same shell or base configurations to all that equipment. You then just tweak those configurations to suit that particular area of the network. So what policies apply to it, what IP addressing and so forth need to be addressed just for that area. Quality of service is a high priority in networks today because of that converged network. We need to provide quality of service so that we can give that priority queuing to the voice and video traffic as we need it. Businesses are now becoming more and more aware of security in modern networks. If you do not have appropriate security, you can lose large amounts of dollars. And business is all about dollars. So management are now starting to become aware of the benefits of actually having money spent on their networks. Fault tolerance in this example here. All right, so we have 2 paths coming out to the internet, and if one of our border routers fails, we have a alternative path, or as they call it, a redundant path, across to our secondary router, our secondary gateway, and we maintain connectivity with a small hiccup. So in theory, everything goes through. In actuality, we lose a little bit of traffic and it has to be resent, because failover is near instantaneous. It isn't always instantaneous. Okay, so the link's got to be detected as being down, it's got to go dead, changeover goes. Scalability, this is what I was talking about by modular design. So there's our module, there's a switch with the PCs connected, cut and paste across, like if it's a new floor in a building that's just been leased, you just expand it up, put a new switch in, and your basic config, your VLANs, which we'll talk about in later chapters, are all replicated and connections are duplicated. You wouldn't necessarily come back to the router because ports on a router are limited. You might have a distribution switch put in underneath that, possibly. Quality of service, as I talked about, is where we allow our telephones to have priority through the network, and basically we want to get it applied as close to the source of the traffic as possible. So worst case scenario, we apply quality of service policies up here on the router. Best practice would be applying it down on the switch so that we immediately get priority service from the switch coming up. Network security. Well, the very basic network security is login and passwords on a, so that's very basic. But when we look at security chapters and that within the course, we'll talk about how we need to secure the physical elements of our infrastructure. So to stop unauthorized access, to maintain the integrity of the media so that people can't tap into it. And we need to basically provide confidentiality of the data, so only the intended recipients get that data. Integrity talks about the making sure the data is not tampered with or modified during transmission, and availability, making sure that the network's there. So there's a trade-off with availability with security. The tighter the security policies, the less available the network. And we'll go into that in greater detail when we look at the security elements. Okay, the trends in business and networking over the last few years has been to open up the enterprise network to allow staff members to bring their own devices and connect to the enterprise. Now, I've got a nice little story out of one of the Cisco conferences. Cisco had a strict policy, like most enterprises back in the day did. You were only allowed their laptop, which was a ThinkPad, their phone, a BlackBerry, on the network. They did an audit. Over a third of their connected devices on their network on the day of the audit were Apples. So iPhones and MacBooks and stuff like that. Because a network interface card, the first half of it identifies the vendor. Okay, so all your iPhones have an identifier saying I'm an Apple product, and same with the IBM network cards and so forth. So that you can quickly find out using the physical addresses of devices what the originating vendor was. So this came as a bit of a shock to the boffins upstairs in management, and they came to realize that, hang on, we employ some of the smartest people in the world, and we're trying to tell them what they can and can't do with a network that we get them to design and build from the ground up. Maybe this isn't the smartest way to conduct business. Because what was happening was they were putting tunnels through their BlackBerries to get access to areas that they were restricted to, and all sorts of funky stuff. If you get a chance to attend these Cisco Live conferences and do some of the information sessions, they open your eyes to some of the activities that happen in the world. So bring your own device is where the company allows you to bring your device that they don't control into the network. There's got to be policies put in place to handle that security. and connection issues therein. But it does allow for greater productivity because people get to use the tools they're most comfortable with and are the fastest with. So there are some benefits to the business to allow that. Collaboration is where we use the ability to share video, voice, files instantaneously and proactively in meetings, and so, like WebEx is Cisco's preferred little software package that they promote. Blue Jeans is the one we use. So you can share files, you can work on the files at the same time throughout the team, throughout the world. So that's online collaboration. Cisco Telepresence is their product for video conferencing, same with WebEx. Their Premier solution is very nice, very expensive, but very nice. You basically go into a conference room that has half a conference desk, and the wall is lined with nice big monitors that show the other half of the conference table, and your video conferencing appear on the monitors as if they're sitting on the other side of the desk. It's very impressive to see. Cloud computing, basically we're using somebody else's services to do all our housekeeping on and provide services over the internet in a secure manner. How secure that is a debate for the security chapter. I have great concerns about clouds and our marketing push just to cut over everything to it. Public and private clouds, well, it's in the name, isn't it? Public, everybody gets to use it. Private, only the individual organisation. Hybrid is where you do a mix of public and private, and custom, well, is a mix of all the above. So power over Ethernet, you may already know, it's where we push power down our category 6 cables and Ethernet cables to our wireless access points. But another concept that a lot of people aren't aware of is where we use the power cabling within your own house or organization to interconnect our networking devices, so power line networking. This was touted as a solution in metro areas and so forth, but there was major concerns about the safety of the data being transmitted, because if it's using main street power as a transport medium, you can monitor the radiation on the power lines and detect all the traffic quite easily. So it never took off as a mainstream service provider level connection, but it's still much a valid solution for in your home. I've used it in a few places I've rented. You don't have to run cables, you just plug the adapter in the wall, you plug your network cable in, and the only proviso is you do not have surge protectors between the power source and the adapter, because the surge protector actually filters off your Ethernet from the power, because you're adding to the sine wave of the power, So when you get to the other end, if you've got a surge protector, it's taking the top off. Yeah, Chris, right, totally, yeah. You can get to areas in your home that your Wi-Fi can't get to, but your power is. Like, I was talking to somebody, I think it was in this group, they said they ran it out to their shed, the garage, okay? So many options available, and when you use it, it's actually quite good. Wireless broadband, yes, we use this quite a lot in Australia. We have our great NBN. Yeah, dear, joke. But it's not available everywhere. So in rural areas, we will use wireless service providers to actually push down broadband services to areas. Now that could be dedicated WiMAX, or it could be cellular, mobile, whatever method. There's lots of different wireless technologies out there. We'll look at that. Okay, it was Christopher. There we go. So, security. Most people, when you start talking about network security, think threats only originate from the outside of a network, so external threats. But the case is only about 20% of threats originate from outside. The rest of it originate from inside your own network. You go, what? Well, you got all these laptops and all these BYO devices coming into your network and connecting on the inside of your network. So it's very easier for a hacker to compromise a business laptop at their home location, where they've let the kids play with the laptop and download those free games off the internet, compromising the business machine. Then you walk back into the network, hook it up, and they now have a legitimate source inside the network that goes out the firewall and allows traffic to come back through the firewall as legitimate traffic. So we need to put in protection internally, not just the big firewall stopping external traffic. So some of the threats are viruses, trojans, all that lovely spyware. Zero-day attacks, you're not going to stop because nobody knows about them until well after they've launched their attack. That's the whole reason for zero-day attacks. Threat actor attacks, denial of service, data interception, identity theft are all different types of threats that networks face. Other ones are employee misuse of facilities, equipment, people knowingly and actively attacking the network from inside because they're pissed with management. Okay. And if an employee loses a device, well, guess what? A hacker can use that device as a source of an attack. So it's very important, if you're a network person, to make sure that all the antivirus and anti-spyware on all your end devices is current and kept up to date on a regular basis. And the same occurs with any firewalls that you have in an organization. Now, antivirus and modern firewalls basically act the same way. They have a database of signature files that identifies types of traffic or characteristics of traffic that need to be matched against, and they identify a malicious attack. So those databases have to be kept up to date. Dedicated firewalls, access control lists, intrusion prevention systems, virtual private networks are all on the upward trend for security solutions. Now, every time you add a service to the network, you need to punch a hole in your firewall to allow that service in and out. That increases your risk of being attacked. As I said, availability and security fight each other. It's a balancing act. So, the sales pitch on behalf of Cisco. Cisco's great. It's fantastic. You need to do your certifications. There you go. Done my sales pitch. Oh, right. They just recently changed all of this, by the way, so this isn't 100% accurate anymore. You still have your CCNA. There are a bucket load of specialist qualifications out there now, and the CCNPs and IEs are still there. But the way you get to increase and maintain your certifications are different now. Basically, when you do the third module, CCNA is in version 7 is now delivered over 3 modules. CCNA, so basically it's the ITN, which is an introduction to the network, routing and switching, and automation, I believe, are the 3 modules off the top of my head. And basically when you get doing the last module, if you average above 70% for all the tests and your final, you basically get the ability to apply for a discount voucher on their exams. So if you progress on into the advanced diploma and continue with this course, you can get a discount on getting your certification exam. Last time I looked at it, they averaged about 50% off the cost. So instead of paying $300, you pay $150, for example. So it's worth it. I mean, it's built into your course. Saves you $100 or whatever when you go to do your certification. Do I recommend CCNA? Yes. Your ITE 1, okay, the IT Essentials maps out to another certification provider called A+. I do not recommend taking A+ certifications. Okay, I don't think they're value for money, and I don't like the politics of the organisation either. So IT Essentials is about building and repairing and maintaining equipment, yet A+ organisation, the company that owns that certification track, actively partition governments not to allow maintenance of equipment. The right to repair bills in America are being lobbied against by that organisation. So they basically going against the members of that buy their certifications. So Cisco through the Netacad are now providing a first touch employment opportunity. So they are allowing employers to basically job posts through the Cisco network, and Cisco Academy students and alumni, which are basically previous graduates of the Academy, can use the system to potentially find employment within the networking community through the Cisco partners and distribution network of employers. It's getting better out there as far as support from this vendor to students and the community at large. So basically, very large brush approach to what networks are, what types of devices are there, what types of networks exist in the world, what the latest trends are, basic connection technologies have all been addressed in today's presentation. Lots of questions, I know, but we've got things to do moving forward now. So on the Cisco site, which if I log in over here, drag it across, there we go, there's a web page. When you log in, and you do have to be logged in to get the resources. Come on, you can do it. There we go. See if a decent instructor would have had this all logged in and prepared today. But you got me. Haha. Alright, so under your resources, you should have a little thing called Packet Tracer. And there it is there, download Packet Tracer. Boom. You're going to need it.
It's a marvelous program, I say.
Okay. Download the 7.3 version. We're doing the latest version of CCNA, so you need the latest version of Packet Tracer. Otherwise, some of the, if you have a 7.2 version, some of the features are not in that version that you need in the other elements of the course. Not so much the first stage, but you will. And what I will do is do an introduction into Packet Tracer and how it all looks and feels as well. Is there anybody still not enrolled in either of these courses on Netacad? So Introduction to Networks and IT Essentials. No, everybody's good. Okay.
I'll tell you in a second.
I think I managed to get you all across into the new one.
I would imagine so. You're pretty good at your job.
Yes, there are chapters. You need to be reading chapter 5 in IT Essentials and chapter 1 in the Internet. So basically, the CCNA course works exactly the same as the IT Essentials course. You launch the course and go in to the various elements. Now, what I really should do is view this as a student because my view and your view are slightly different. So go to modules to find content assessments. Okay. Download latest packet tracer. So if you scroll down, the exams are going to be different. See here, they do combined exams. They don't do individual chapter exams. And then you've got to come in here and actually launch the course from in there. It's a pain. But it's the way it works. Yeah, all right. So you go through your modules section and then into your course, and then Canvas will fire up in a new window for you. Looks a little different, but these are basically the chapters down through here. And there's a few extra chapters, so I've got to rework. There'll be a couple of weeks where we've got to do multiple chapters in the week. But this week I'm just keeping it to the one because chapter 5 and chapter 1 are fairly big chapters for both courses, all dealing with networking. But if you download Packet Tracer, you should get a little icon installed on your computer. It uses your Cisco Netacad login. So to unlock the full functionality, you use your Netacad credentials, so your email that you're registered with the Netacad, and the password you have for your Netacad course. And you have Packet Tracer. Now, Packet Tracer, the basics of it, just to give you a very quick rundown through this simulation, is down here you have your devices. So the first box there, and then the sub menus are available along the bottom. So the first one's your routers, then you click the next one for your switches, and across as we go through. So to use them, you just click on the one that you want, such as the 2811, drag it in. It should be fast, yes. It's not a very big program. Okay, I want to switch, which will be the basic things these two devices will be working around with. There are dedicated Packet Tracer activities throughout the course that you download the activity and open up in Packet Tracer. And they have full instructions on step-in-step instructions for the lab to work your way through what you're supposed to be doing. You need, the next one across is your end devices, so your phones, TVs, laptops, PCs. So we can just whack those around. Now, you can double click on the device and I'll bring it up the physical characteristics. Now this one, basically big holes, but you can look at and change things. Now, turned on. If you want to change something, got to turn it off. Drag what you want into the point. Okay, so you just drag, put the module cards in when you got the appropriate module cards. Now, when you do the labs, it will tell you which cards to drop into the equipment. You then got to turn it back on. Now, there's two. Still booting, yes, I know. Command line. I recommend you do all your config via the command line. This is the actual representation of the command line you would face when you connect to the individual device. I strongly recommend you do this practice using the command line. And I will, when we get a little bit further in, I will do a dedicated scenario with showing you how to do basic config and everything. But I just want to give you the basics of Packet Tracer, because it asks you to download and install Packet Tracer as the first activity. I think it provides one activity within Chapter 1 that needs Packet Tracer. So I will do all my demonstrations using the command line interface and explain everything using connections and that regarding this. Now, this config line here is shortcut. Okay, click on the interface, type it in, and it'll show you what the commands are down the bottom. So if I just type in an address like I would on a computer with a subnet mask, there it is, that's the address. Down the bottom, that's the command and where I've got to put it. You don't actually need to know how to config using the config screen. Alright. By doing it and understanding the command line, it's actually what you will need to do on real life equipment. Command line. You don't have this wizard available on live equipment. You only have the command line. So I will be teaching everything through command line interface as if it was live equipment. All right. Media, look at the lightning bolt, and this is all your media types that you have throughout Packet Tracer. Now, I'm going to do separate presentations just on Packet Tracer, and I'll do recordings just on Packet Tracer to post up. This is just the application. We're going to use it to simulate equipment and build networks in and do labs in. So I want you to get used to the interface, have a play. Okay. I'll do a whole series of presentations on examples within Packet Tracer. But I figured between Chapter 5 in ITE and reading Chapter 1 in Season A, you have enough to take in today. Does that make sense? Yeah.
Yep.
All right.